Hi, my name's Matt,
And I'm John.
and today we're going to tell you about agents. 6 months ago, AI could write you a poem, but today it can run your entire research department. And 6 months from now, McKinsey predicts that 40% of business tasks will be handled by autonomous agents. And we're not talking about the future anymore. 2025 is the year of the agent, and it's happening right now. While we're sitting in this room, early adopters are building agents that will make their teams 10 times more productive. The question isn't whether agents will transform your work, it's whether you'll be using them or competing against them.
We're going to explore a spectrum of AI technologies from simple text generators to agents that act, decide, and adapt. Before we dive into agents, let's level set.
When we talk about AI and agentic AI, what do we mean? Essentially, AI, as some have said, is machine learning with a marketing department. But artificial intelligence performs tasks typically required human intelligence. It's a soft and fuzzy, inaccurate definition, but for us today, AI systems have intelligent-like behavior, recognizing faces, translating language, predicting stock trends, and beyond. The technologies underlying these systems are often large language models, or LLMs. These are trained on massive amounts of text from the internet, and it's a probability model with predictive capabilities. This predictive capability is accurate, but there's also what some people describe as emergent behavior. See, when you train these models on enough text, they start doing things that can't fully be explained by this probabilistic behavior. Anyhow, this helps you understand that there are things that we don't yet know about these models. We know that they don't have emotions, we know that they don't know facts inherently, and we know that they don't have goals. And see, this last one is important because I'm going to show you how we use LLMs to come up with goals and plans.
So let's start with a simple example of an LLM. With a standard LLM, we could write something like, write a haiku about coffee. We have a user sending a prompt to a model, and the model returns text. The prompt I sent was, write a haiku about coffee, and the model returned, afternoon warmth in hand. But is this agentic behavior? No, it's not an agent. Here's why. LLMs don't remember. In computer science terms, we say they're stateless. The model won't remember what you gave it yesterday or last week. Each prompt is independent. They're reactive, not proactive. And they're not autonomous. That being said, LLMs are still extremely useful. We have writing assistants, coding copilots, customer service bots, etc. But until this year, all of these things required strong human oversight.
But agents are a completely different framework than just LLMs. Agents scale or augment repetitive tasks. They're systems that do things for us. They adapt based on feedback or coordinate multiple steps through a workflow. Agents are more than a smart typewriter predicting the next word. All right, pop quiz. Is this an agent? Let's go through a thought experiment here. A user wants to draft a LinkedIn post about, let's say, Duke and AI. In the normal behavior, a user sends a prompt to the LLM. The LLM returns a response. The user posts on LinkedIn. Is this an agent? No, this is not.
Now let's consider a second example with tool use. Tools give LLMs access to search engines, databases, or APIs. This allows the LLM to retrieve information or even take actions on your behalf. Let's build up the LinkedIn example. Suppose you prompt, draft and post on LinkedIn for me an article about Duke and AI. The LLM writes the post, then accesses the LinkedIn API. An API, or application programming interface, is how computers talk to other computers. LinkedIn makes an API that allows authorized access to their servers. Is this an agent? I would argue tool use alone is not the defining feature of an agent.
All right, next example. Let's chain LLM calls together. So let's say we wanted to summarize notes from this amazing video, extract some keywords, and then use those keywords to draft a LinkedIn post. Is this an agent because it uses multiple chains of queries? I would still say no. Calling a tool and feeding it to an LLM, or taking the output of one LLM and feeding it to another one is not sufficient to be an agent. Those are just multiple queries.
An agent has 3 essential steps. The first is plan or think. Let's come up with a plan. The second one is act. Let's take that plan and let's do something. Let's execute the plan. And the third is observe. Let's then observe what happened and decide what to do next. So this is the core loop. Thought, what should I do? Action, let's use a tool, let's generate text, let's interact with an API. And then observation, did that work? Have I completed my task? Or do I need a different approach? The agent then repeats this loop until it meets the criteria based on observation for terminating.
Exactly. So let's go back to our LinkedIn example. An agent would plan, it would research, it would draft content, and it would post. It then executes this with loops. During the research phase, it might use web browser tools like Access Google. It then continues until the LLM decides the research is done. The LLM determines when each step is complete based on your original request. Now, this is important. This doneness value is based on the very first request. If you say research, draft, and post on LinkedIn for me, it determines when the research is done, when the drafting is done, and when the posting is done. Now, all of this is still LLM based. See, the same language models you use every day are also the language models that are driving agentic behavior. You could ask an LLM to write something, or you could ask it to come up with a plan. This is one of the most transformative uses of AI. Ask it to create a learning plan, and it will lay out that educational plan for you. It's pretty amazing.
It is. So what makes something an agent? It's not just about text generation. It's not just about using tools. It's not about following a script. It's about autonomous planning and action. So how are these agents being used right now? There are several examples that are currently available to us. A first example would be deep research tools, such as deep research from ChatGPT. If you give it a research request, it'll determine when the research is done based on your criteria. If you ask for a high-level overview of a topic, it might take a couple of minutes. If you ask for a specific, deep question, it might take an hour or two, going through hundreds of references to answer your question. The LM isn't deciding like a graduate student would or a child would decide when homework is done. It determines task completion based on the original criteria you gave it. You are still determining what done means. The LLM then grades its output based on your input.
Another example are content creation bots. These go through LinkedIn, create posts, and publish automatically. See, some don't even take human input. They'll research AI news, determine what's performing best, create bullet points, draft posts, and eventually generate images and publish. Now, you have bots talking to bots to create material. It's a crazy future that's happening today.
Another example that many of you have seen is automated customer service. Voice models are now more realistic than ever. We've crossed the uncanny valley, that point where we can't tell the difference between AI voices and human voices. So now, when you call customer service, instead of repeatedly pressing 0 to reach an operator, AI could solve your problem in 5 minutes rather than sitting on hold for an hour waiting for a human operator.
Are you an AI bot, John?
I guess we'd never know, would we?
All right. Now, some of these agents sound really helpful, but they come with increased risks and also different kind of risks. When you give actions and autonomy to agents, there's a couple of unique things to consider. So for example, hallucinations, which we all heard about within LLMs, can propagate. So imagine a travel agent bot planning your itinerary. You say, I want to go to Paris. It seems like a lovely place to visit this time of year. It creates an entire itinerary, purchases tickets, hotels, and everything. Now, the problem is, if it gets the wrong Paris at the very first step, then you might end up in Paris, Texas, instead of Paris, France.
Another way that things can go wrong is failure to stop. Because agents run in a loop, we might use a shopping agent, for example, and ask it to purchase a handbag for us. But that agent might purchase a first handbag, look and determine if you've received the handbag, and come to the conclusion, no, so we better loop back and do it again. And it might continue to do this and purchase more and more handbags for you.
Another risk of agents is incomplete reasoning. So imagine an agent that is going to determine the diagnosis of a patient. Let's say a woman reports fatigue, nausea, abdominal bloating, and her missed period. The agent suggests gastrointestinal upset or stress-related menstruation delay. Clearly, there's some incomplete information that the agent isn't seeing.
And another way that things can go wrong is tool misuse. Because an AI is controlling tools, it's possible that you may get unexpected results. Suppose an AI posts on social media on your behalf, William didn't do too much on this project. He attended just 2 meetings and was CC'd on a lot of emails. Or maybe you're buying something on eBay and your agent posts, seller is desperate, try lowballing. There's a future where these are helpful, but there's also elevated importance in monitoring every step of the process an agent goes through. You can engineer safeguards, maybe send an email for approval before posting on social media, for example. You should always be in the loop to ensure the proper behavior of the agent.
So we then think of a framework, a simple way of knowing when to use agents and when not. We can use agents when the cost of errors is low, the task is structured or repetitive with little variance, the volume is unfeasible for humans and would be benefited by agents, or you need to do something quite quickly that maybe humans couldn't accomplish.
And the types of situations we may choose not to use agents are situations when the cost of errors is high. Maybe the financial cost, emotional cost, areas like healthcare would be a great example. Or perhaps we're trying to accomplish a task that's highly creative or open-ended. These are tasks that agents can often struggle with. A final situation might be something that's very low volume. We're just doing it once or twice, and it's mission critical. And so that may be an area where it's important enough to really do it by hand. So this is a framework to understand how these systems work, to look under the hood and ask, is it thinking and planning? Is it acting? Does it observe and decide?
All right, in my next video, I'm going to show you how to use agents with several of the commonly available tools in 2025.
And in my next video, I'm going to show you how to build custom agents using simple Python code.
We started by talking about 2025 as the year of the agent, but here's the thing, 2025 is now. While everyone is still trying to figure out what ChatGPT is, you can be building agents that transform how you work. You don't need to be a programmer, you don't need a huge budget, you just need to start. Try one agent this week. Build one automation. Maybe replace one repetitive task. Because once you see what 8 hours of work done in 30 minutes feels like, you're never going to go back. Welcome to the age of the agents. Let's build something amazing.